Okay, so when we talk about Linux, we mainly talks about having the operating system which is dominant in the data in the world of data centers and in the world of IT as well. So we are we have some understanding of the operating system. We are using a desktop operating system. Most of the people might be using Windows or Mac, and some of them might have also used Linux as well. So nowadays Linux is shipped with the desktop version as well. But back in the day, Linux was before 2000. I mean, not even that back in the history. Before 2000, Linux was only a server. And before 80s, I mean, all you had was just a server. You had this black and white screen where you just gonna type the command. There was no graphic things anywhere. It wasn't very user friendly. It was all intimidating. So we will take a step back and try to understand before operating system what are the things that we need to know, or at least we should have a basic understanding. So I'll start with the IT infrastructure. We'll start looking into components that falls into IT infrastructure, right? Like I say this, we in the human society have our own infrastructure. Similarly, IT also has its infrastructure, and IT infrastructure starts with the data centers. First thing, you want to have a data center. Now, the data center is nothing but a big, gigantic house or a warehouse where you store all the servers. And this, there are so many things that goes behind it, that goes along with that. In order to, if you are a company and you want to host your own data center, there are certain things which you need to be worried about, which you need to take into consideration. I would request everyone to mute yourself, and if you have any questions anytime right in between, just raise your hand, and I would encourage you to interact and ask questions. Any questions you have, any misconception or any query or any doubt, just throw it on the floor, right? And I'll be more than happy to address it. So don't shy away from asking questions, because asking questions will make your understanding good and strong, and that's the whole purpose why we are here. It's to get you a foundational understanding, and you should have a grip on the topics that we are discussing. So if you talk about data centers, data center is like a warehouse. It's like a gigantic house where you have a lot of computers. We call them servers, right? And server is nothing but it acts just like PC or computers. Your laptop, you can also consider or think of laptop as a server, but technically that's not right. It can give you some extent, it can give you pretty much all the functionality of the server if you want. And nowadays servers are with, it's not just the operating system that makes up for the server like we have on our laptop. We have operating system, we have a hardware. On top of the hardware, we install operating system. On top of the operating system, we install applications like browsers. The one application that I'm using right now is Chrome, and the other application, the Opera. So these are all the applications installed on my hardware, right? So for selection of data center, like where you want to host your data center, there are a lot of things that goes with that, right? You can't just have host your data center any way you like. I mean, because you use a laptop, and everybody run into this issue of the heating, right? Your laptop's gonna heat up if you overuse it, and if you use it for maybe for 4 hours, 5 hours, if you run application which is consuming a lot of resources, your laptop is gonna laptop will start heating, or your PC, if you have that's also going to start heating as well. And that's a problem we run into when we are running applications, when we consume a lot of power. So these servers, they are actually dedicated to run 24/7. So they generate a huge amount of heat, and that's the reason why we want to when you do a data center selection, you need to select a place which is cool, I mean, naturally, which is not very, where there is a less heat, in terms of the sun and other things. So you don't want to create your data center in the middle of somewhere, in the Sahara Desert or somewhere where you have a lot of natural calamities, because you cannot afford your server to go down as well. I mean, you don't want to host your server uh, where there are like constant floods are there, earthquakes are there, because when you create your application, just imagine Google going down, right? That becomes a breaking news. So Google cannot afford to host their server somewhere where they run into so many problems. So the location where you're gonna create your data center, the location matters, and the selection of location is also something you'll have to do that. Plus, when you select the location, you'll have to also work with the regulations, the government regulations and the compliances for that particular country. And if you have customers, that customer probably gonna have a lot of data that you are storing, right? Because that's why we call it data centers, because you store all sort of data in the, it's one of your center where you store all the data. So your server, I mean, everything that we are storing is just the data. So in order to create this data center where we're going to host all of these servers or computers which will have store the data, is the location, right? And I've also mentioned another thing is the resource. So in the IT infrastructure, we have few resources, and we are actually talking about to get these resources. So I will write this down, the resources which are very common and which is very important that everyone should know. Maybe you should just cram it if you want, because these are the important resources. And throughout your whole IT career, you will be dealing with these resources, whether you want more of that resource, you want less of that resource, you want to optimize it, you want to spend some money for the consumption of that resource, and so on and so forth. So one of the resource is computing, or it's a compute resource, which is combination of RAM and CPU. So you're going to have that. Another one is storage, and another one is NIC. Now, NIC is your network interface card, or networking. NIC is the person who will give you the identity. Like, we all have identities, right? I have identity. I have a name, right? I have name, that is my identity, plus my address as well, because there will be so many people with the same name, right? There will be another persons as well. But me, my name and my address, that is the unique identity I have. You have social numbers, and you have some kind of ways to determine that this person is unique, because he has this number or whatever SSN, or the way it works for you guys. So generally, to keep it simple, you have a name and you have address. Now that is your uniqueness and that is your identity. Similarly, when we create the resources or when we create the servers, they also have the identity, and that identity is possible with the help of NIC. We'll explore all of these resources, a little bit in detail to get more understanding, but something which I will be repeating over and over, and you should have this registered in your head, that these are the resources that I need to be mindful of, or I need to be aware of. Okay, so coming back to data center, the selection for the location. So you want to choose the location, and then you have to worry about the other compliances, the regulatories, wherever you are hosting the data. There are so many different compliances you have. If you're working with, if your business is to deal with the finances, you have different compliances for the finance, plus that particular local compliances will also be there for that particular region. If you are working somewhere in Europe, if you are working somewhere in Asia, Africa, whatever country you have, so you'll have to be compliant with that compliances. So you need to take that into consideration as well. Plus, you need the power. Like I said, these are the servers. These are not your laptops or your home computers where you just run it when you want. You have to run these servers 24/7. So you're going to need some kind of, a power, or generally we have the grades of power. It's not one power that is enough. Plus, on top of power, you're going to need the backup as well, because you can't simply afford your server to go down, or whatever the application wherever you're hosting, you cannot afford that to be shuts off, because that's actually going to have the impact on your business, and it is not very desirable, which is not accepted at all, right? So there are DR strategies are going on. DR is just a disaster recovery. When disaster happens, when any sort of failure happens, how do we make sure that we keep our business up and running? Business continuity plan, BCP is generally, so you have DR strategy for your BCP, which is business continuity plan. So whenever these sort of the calamities, the disasters take place, how do we make sure that our business continues to function or it continues to run? Right. So just for the people who are joining late, mute yourself. So yeah, there is no disturbance. So we have power grids, and we have so many servers running 24/7. So you can only imagine now the amount of heat it will generate. So you're going to need a chiller plants. So these are the things which you're going to have in the data centers. So you're going to have a chiller plants, the cooling, the cooling mechanisms as well. There will be units and units of, for the cooling. I mean, chiller plants is, it's actually going to pave a way for your coolings and different air conditionings that you want to have. And then you'll have, you're going to want to have a racks, and each racks will have its own connectivity with the network. And then there will be different backups and restores as well. So these are, it's just the starting point of the. So these are again, the starting points of your data centers. So I have one image that actually illustrate. Let me just get this. So generally, you need all of these sort of, and then there are securities are also there, right? The network security, the physical security. You have the virtual security, the physical security. Anybody can barge in, anybody can get in. There are data centers which are kept so confidential, like government data centers, like data center for the NASA, data center for the America or India or any other countries. You have so many different countries. So their data centers needs to be kept discreet and at a confident, at a location that nobody knows. So when they have certain works, some repair works or some work that they want to get it done, and they're bringing the laborers or the other people, they simply blindfold them, right? How you see in the movies. That actually the reality, because you want to keep it discreet, you want to keep it very confidential. Now, Microsoft have done one extra level by planting their data centers beneath the water, because they want it to be a pool, right? They want to have, so they are saving now. When they do all sort of things, right, whatever you have, it has a very massive impact. The heat exchangers, the cooling systems, the air conditions, they have a very massive impact on the global warming, because they are actually emitting a lot of gases which are not very very friendly to the nature. So all of these are they're constantly working to make it as eco-friendly as possible for the nature. And one of the effort that they have done is, Microsoft recently tried by planting their data center beneath the ocean or beneath the water, I would say, under the river. And they did that experiment, and it worked quite well. I think they had years, and so they're working with the different strategies. They're hosting the data centers, in the in the region where there is a lot of icing regions. You have Iceland and other locations where you have a lot of it's cool all the time, just to save on the other resources that they might have to invest if they had to do that, but if they had to do it in other country. But at the same time, you cannot have everything there. What if that country face some natural calamity? Your whole data center will go down. So you want to have a DR site, you want to have a disaster recovery or a backup data center somewhere else. That works in terms of the accessibility as well. Like if you host all your data center in Iceland, let's say, for example, and you have users in USA, you have users in Australian region, you have users in Asian region, they're gonna have a very they'll face a latency, right? So this is another term that is very commonly used in the IT. So I'm just writing it down so you guys can also get an idea, and when you understand the actual meaning of it, so you can use in your conversation as well. So you don't find it something new or something you don't understand and you struggle. So latency is whenever you are connecting to something and you are taking time. I mean, latency is actually driven from the word late. So whenever you're supposed to reach somewhere on time, but you are reaching there late, basically you have latency. Right? That's what we call in the IT terms. So you'll have a lot of latency if your data center is in the Iceland. The server that you have is on the Iceland. There is some website running on top of that server, and you are connecting from the Indian region or probably from the Australian region. If you are in a Europe, maybe you are fast, you'll quickly connect. But if you are in a different region, that's you're gonna have a difficult time to connect to that particular region because that country is only there. So for that as well, right? They companies are actually doing edge location data centers as well. Like they have edge points. Edge points is me. So we all connect to Amazon.com, right? Which is the American website or American company. So the initial thought would be, okay, this is American company, so they'll have the data center and their whole business running in the America. So they do have their websites in the America or the United States, but they have actually have the edge points everywhere across the globe, and that actually makes it easy for the users to connect wherever they are from. If I'm connecting from the India, if somebody is connecting from Nigeria or somebody is connecting from Australia, they are not routed all the way to the server which is there in the United States. Rather, they are actually connecting to the the edge point which is there, which is the nearest to them, and that's how everybody connects pretty fast. All of these are possible having the redundancy. Redundancy is the word again. It's again a common word that is used in the IT, which is repeat, right? You have more than one. So when we talk redundancy in the IT, basically we are talking about more than once or repetition, right? The literal English means is repeating. And when you have a redundant servers, basically you are repeating the number of servers or number of data centers as well. So you want to have all of these in order to create your own data center. Now imagine you are a startup company and you want to get started, and your core of you are not IT person. You are just doing some sort of a business which is sell clothes or sell some textile merchandise. You have that. You don't have any you are like an expert in your industry or in your line of work, but you don't know anything about IT, and you want to get started. You're not a very big firm. You are just a small size business, and you want to grow. And the fastest way to grow is to get your presence on the digital. You come to the internet and you have your scope to sell it across the whole world, and you can run your business 24/7, because when you own a shop, you can only run during the working hours, right? During the daytimes, because at the night time you want to go to sleep. So you'll close your shops and then you'll go back to your home. You're going to eat, spend some time with the family, eat and sleep. But when you have the digital presence, basically you're running your business 24/7, and you have the very high chances of running it across the globe everywhere. So you have a very high scope, and that's something you want for your business to grow. But you're not an IT person. And when you look at the requirement, okay, the first thing I have to do in order to create my website is to have the data center. I'm going to need a data center. It cannot be a huge or gigantic data center, but I would still need data centers with at least 4 to 5 servers to get started. And even for that 4 to 5 servers to get started, I would have to have a power grid that has the backup. So there is a lot of power consumptions. I'm going to need the chiller plants for the cooling. The racks I will have, because I'll have to keep it in a systematic. I just can't throw them, and make it a very messy setup with the wiring and cables and etc. So, and then I'll have to worry about the network and the backups and etc. So I'm thinking, okay, I don't know about this. That's not a good idea. Let's not go for it, right? So that's what the startups were not very keen to move to the internet, or at least on the digital, before 2010, right? Because they had to go through all of these, and whatever you do here, right, these are all your capex. So again, a common word which you hear a lot in the cloud computing is CapEx and OpEx. CapEx is your capital expenditure and OpEx is your operational expenditure, right? So, I mean, these are like operational expenditure is where you have to, like you have the textile business or merchandise business. You're gonna have you'll have to keep a salesman that will keep your business running, right? So that salary to the salesman is your OpEx, and the shop that you're going to own, the product that you'll buy, the clothes that you'll keep in your shop, those are all your capital expenditure. That's something you have to invest. And going for a digital presence, you're going to have to spend here as well. So these are all your capital expenditure, and when you look at that and when you take that into account, you're like, okay, you know what, let's not do that because we don't have money that much. And that's what actually literally that's what happened before 2010 to all the startup, all the companies which were starting up, which was a relatively small size. They didn't have the budget, they didn't have the capacity to go digital or have that presence on the internet, right? So that was not possible because they had to have this. I mean, having this is one challenge, but then maintaining is another challenge, right? You're gonna need those type of people. What will you do when your power grid fails? Something happens, some failures happen. You're gonna have to call the electrician or the expert person who can manage that. You have the location, you have the warehouse, you can have the physical, you can, the wall can be damaged, the windows can get damaged as well. So who's going to repair that? There will be so many different things as well that you have to take care. So you have one challenge is to invest the money to build all of these, and then you have another challenge to sustain all of this. So it's not very easy. It's not something you can just do it on the fly, or so there was a capex expenditure or capital expenditure was involved, and that made very hard for small businesses and companies to invest their money on. So why we hear now so many startups, so many companies or startups that are turning to be unicorn, and then they are turning out to be a big player, which is then acquired by another big major players like Google, Amazon. We keep hearing on the news that Amazon have acquired someone. Recently, Google has acquired one more company, and before that, they acquired another company, which was another startup, which was doing very good in the migrations, the cloud migrations that they were performing. So Google acquired them because they were doing very good. And we keep on hearing, if you subscribe to those sort of newsletters, right, you'll hear a lot of news that these big giants or big fish, they are actually acquiring the small fishes. That's the nature. I mean, if you want to kill the competition, that's what you do, right? So that's what they're doing. So the point is now so many startups are popping up, and that actually is possible because we have something called data centers of the cloud data center, where you don't have to put the capex, you only worry about the opex, right? And we'll see that as well. We'll see now, the different types of data centers. So first type of data center is where you take care of all of these, and that data center we call is enterprise data center or privately held data centers, where you have to take care of everything that that I've shown here. And those data center, I have one example of that data center. So this is the a very small, a relatively small setup of the data center, where you have racks. Racks is like a cupboard that you have in your house, like a wardrobe sort of thing, where you just you just slide your servers inside it, and you keep them on on top of each other, and then you do the cabling and wiring behind the scenes, all sort of things. You can always find the difference. People have created their own data centers. The small companies have data centers, which is probably like a 400, 500 square feet of house, where they have different setups, and the AC and other cooling systems are also available there. So these are the enterprise data center, where you pretty much have to take care of everything that I have just mentioned. And these are something possible for companies like big companies, right? And at least the Fortune 500 companies. So something, if you have not heard or seen, let me just show you. So Fortune 500 companies, I mean, I'm just giving you an example. This is so much affordable for Fortune 500 companies to actually go for it. I mean, other than Fortune 500 companies can also do that. That's not a problem, but they'll do it on a very small scale. But companies like these, the companies like Walmart and Amazon, now these are not a IT company, right? Because the main domain of business is not in IT. Their domain of business is something else. Okay, I see one hand from the Bradley. Yes, Bradley, go ahead. Do you have question? You can unmute. Okay. Okay, I guess it was accidental. Fine. So, I mean, these are the companies: Walmart, Amazon. The Apple is, they do deal with hardware manufacturing, and they have their own software as well. But again, they are not, service provider for the IT. Like, they are not providing service like IBM does. They are not providing services like TCS does, and the other, IT service providing companies that that are there in the market. Now, Alphabet is the only company that I see in the list, which is actually in the IT, because Alphabet is the company which is the parent company of the Google, and all other, the others they have within this company. So these companies can go on and afford to have their own data center, right? They have the power, they have the money, they have the resources, and they can pretty much go and do that. So Fortune 500 companies can easily afford to do it. One more thing that we call, I mean, these companies that we see here, right? So in IT, any service that is any company that is not providing IT services, we simply call them product-based company. Product-based companies or organization, and any company that is providing IT services, we call them service-based companies. I mean, this is also a very common term that everybody uses in the IT. It's a product-based company, it's a service-based company, it's a service industry, product industry. So this is what they mean. I mean, every business is there because they are providing some kind of a service. The service that they're not providing, which is related to IT, they simply go, they are known as the product-based company. Like Walmart is not providing IT service, right? They don't provide, but they are turning into be the IT company. I mean, the Google is considered to be right now visionary in the IT, and a lot of people also make a statement that Google is ahead of the other companies. They are 10 years ahead, 15 years ahead of the other company in terms of the technology, and they predict the futures as well. So Google has said two things, that every company in the future is going to be the data company, and that's, that had been from the beginning, and that's the reason why we call it data center. We don't call it server center or computer center. We simply call it data center because you store a lot of data, and data have been a very integral part of any business from any point of time, right? We have data from the beginning of the time. People are storing in different forms. So data plays a very vital role in human life and in also the corporate business and the different business, different industries as well. So that's why the data is very common, and Google has made that statement that in future every company is going to be a data company, and every company is also going to be the IT company as well. Now, the Walmart is not IT company. The Amazon is not. I mean, Amazon have their AWS, right, which is not which is part of the Amazon, but Amazon is not AWS. They have their a sister company or another company within that, which is doing the business in the IT. So, you have that way. Apple is the same thing, and all of these big giants, because what they are doing, the Netflix is a very good example. Netflix have contributed a lot of open source tools, a lot of software. Netflix is the pioneer for the microservices. They were the one who first implemented the microservice outside of the Google. I mean, it was all Google because they were doing it, but they were not. They were doing it closed door. They didn't let everyone. They did not open source the technology, and that's how not everyone knows that. But they did actually let everyone know their idea by in the form of white papers, right? I'll show you the I'll talk about the white papers as well, which is what That's the way to actually put your the technology or idea into the market. And these white papers, they actually they're going to charge you around $3,000 to $5,000 to buy these white papers. And in the organization you have C-suite, and that C-suites buy these white papers, and these are published by our media, and sometimes these are also published by the companies themselves directly. So Google, what they have done, they publish, okay, how we are handling the business, and it is a mandatory part of the they have their own regulations. As a part of the regulation, they have to they have to publish these white paper as well. And white paper is something for who doesn't understand the technology. It's a plain English thing. It's based on the market research. It's like a research paper, right? I mean, white paper is nothing but a research paper. So it can be a research paper, and it can also be a result as well, because when business media like Forbes, Gartner, IDC, I mean, these are the very common names that you'll hear as well from your top management, that they are attending the Gartner summit, the Gartner conference. Gartner said this, Gartner said that. Gartner has actually published the definition for the new things, whatever is going on in the IT. So the definition for the cloud computing, the definition for the data centers. So they are the one actually coming up with the formal definitions, and then everybody follows in the IT. So these business medias, they are doing a research. They have the expert people who are constantly, they're down in the market. They're doing all sort of research, and then publishing the reports to everyone to know. So they publish the reports or research in the form of white papers. At the same time, companies like Google and Amazon and Walmart, they also publish that. They also want to have their presence in the IT. And like Google said, every company is going to be the IT company in the future. And so they are doing a lot of contributions. And these are the companies who can actually afford to have the enterprise data centers. They can create their own data center. They can manage this whole complexity that you see here, and they can afford to have people, and they can feed them as well, as in they can put them in the payroll, and they can give them salary. So they can do that. They have the capacity, they have the money, but it's not possible for the mid-size or small size or startups. You have the big size of organization which can very much afford to do that, but the other side cannot do it. So you have this enterprise data center. There is another type of data center which is very much common, and again, before cloud computing, which it has taken some rise, but now with the way cloud computing have actually taken with the storm, these type of data center are also surviving, and companies are going for it. Maybe startups don't go for it, but again, small size or mid-size companies, they go it, and they are as affordable as the cloud computing, and plus you have extra level of flexibility. So these are like colocation or colo facilities. Where what happens, these things will be, I mean, after all of these, right, what you need is the server, and then server, you need a virtualization, which we'll see in a moment, and then you need virtualization, you need operating system, you need then you need then your application, whatever you're running, and that's the reason why you have. So you can get one of these colocation. What they will do, the way this works is, they'll give you a cage, right, and they'll take care of everything, the location, everything that is other than the non-server thing, right? So the collocations are like this. So this is one of the cage. Inside cage, they will also provide you the rack, the connectivity, the cables, the various backup within all of these that you have. So everything will be provided except the servers. You bring your own servers, you bring your own admins, and then you manage the servers and only the admin. Anything other than please mute. Okay, anything other than that fails, it will be taken care by the colo facilities, or the people who are providing you, I mean the vendor, whoever is providing you the facility. So co-location or colo facilities are very common, and they are also on the rise and competing with the cloud computing thing. And what I've seen, a lot of companies, they are moving as well. The only benefit that they don't, I mean, people are moving to the private cloud now. I mean, people as in the organizations, and I'm not sure how far they can go with that. And again, having a private cloud also gives a different opens different doors of challenges which not every company is going to handle, or at least the way things are right now, it's not feasible for all companies or non-IT companies, for non-IT startup to handle those. So they'll continue to be on the on the cloud. But other than that, the established companies, the establishments, they are actually going for the co-location facilities where you get a cage, and inside cage you have the racks and everything is taken care. You bring your own servers, you plug it in, and then you use it, right? And the rest of the thing will be taken care by them. This is also from the, there are different compliances for the different data compliances which do not comply with the cloud computing, because your server or your storage system is being managed by someone else. In this case, that's not the case. Your server and the data center is managed by your people, the people who certified to manage or handle the data of your customers. So you actually comply to that as well, and you get you are there to the compliances. For that reason also, a lot of companies, they're moving to this. And then we have one more type, like which is very much used, which is the cloud data centers. Here, this is a combination of all of these two, right? You don't worry about all of these that we have seen here. Everything is being managed by the vendor, plus the server is also managed, plus the operating system is also managed by the vendors. So anybody has any question, please raise hands. Right? No necessary, please avoid unmuting yourself in between. Okay, so that's the way like the cloud data centers are. You don't worry about anything, you just get an up and running, right? And that's how the cloud data centers are made up of. So it's a combination of these two you can think of. But again, I mean, when you do that, here you have a lot of flexibility, but again the flexibility comes with the responsibility. You have again, you don't have flexibility as much as you would have had if you had the enterprise data center, but the responsibility is also taken off here. Because less responsibility equals less flexibility, right? That's the formula we put it here. Less flexibility. On cloud, you only have the server, and you can choose the operating system, and within the cloud also you have different types of services as well. And then there are different types of companies as well. You have company like Heroku, who doesn't give you a choice of choosing operating system. You just choose the runtime environment. So Heroku is only specialized providing you a PaaS-based services. So here we have IaaS, PaaS, which we will see that as well, and then we have SaaS. So then there are companies who are only providing you SaaS, there are companies who are only providing you PaaS, and then there are companies who are providing you all three of those. So there are different levels as well within the cloud. And then you have everything as service. These are the three, and whatever you have, right, other than that, I mean, you can have a function as a service, database as a service, whatever as a service you can name it, right? So there is one thing they call it X is a placeholder, and you can just name your application as a service, right? So if you have grown some application, the homegrown application, you can just provide that as a SaaS-based offering, and you can call that as a service. Everything else as a service, right? That's X here stands for. So there are companies like Salesforce, there are companies like SAP, there are company like TIPCO. They will give you a SaaS-based offering. Then there are companies like Heroku and others who will give you a PaaS-based services. They don't allow you to choose operating system. They'll just give you run times where you can bring your application, bring your code and run it. And then there are companies like Amazon, Google, AWS, which will give you all three of those. They'll give you infrastructure as a service where you can choose the operating system, but you cannot choose beneath that, like what is the hypervisor you're going to need. We'll look into that as well. So this happens. Less responsibility, less flexibility. You don't need to choose that. And within the data center, you have these two where you have even less flexibility because the other responsibilities are also taken out from here. On the infrastructure as a service, actually you have some more responsibility, and that's how you get some more flexibility as well. And when you go down the ranks to the PaaS and SaaS, everything is eliminated. I mean, you don't have a lot of flexibility, so you don't have responsibility as well. And the newest type of the data centers that we have, right, which is again everywhere, and which is considered to be the future again, is the edge data centers, right? And edge data centers is, you know, just a combination of the rest of the three. So they're just edge data center is for your you know, you might have heard Internet of Everything, right? Internet of Things, IoT devices that are there, the sensors are there, the you know, the cameras are there. So everything is capturing the devices. You have a lot of smart appliances. You have the microwave, fridge, TV, house, a door, I mean the car. Everything is generating a lot of data, right? And these data needs to be captured. And so all the provider, right? If you buy a car, so your car is actually generating a lot of data, and that data needs to be transmitted to some storage system, and that storage system needs to be kept nearby. Edge data center is again coming the concept from the CDN, which we will see that later in the lecture as well. They are actually located very close to your devices, right? So all the things that we are hearing about for the IoT devices, right? So edge data centers are for the IoT devices. It's kept very near to the consumers or the users who are actually using it. So you have IoT devices, you have the edge data centers, which is useful for the IoT devices, the ML, AI, data science, you know, all those sort of things. So that is going on in the market nowadays. So you have that in the data centers. Our focus is going to be here, at least for the rest of the lab, is going to be on the cloud data centers, and cloud data center is at a rise as well. Now, edge data center is for the people who are actually pursuing a career in the data engineering field, right? If you are on the data engineering field, you can start with the cloud data centers, and then maybe you'll deal with that edge data center, which is nothing but same as the cloud data center, because here you just have a lot of data, and you should know the different data techniques, the data technologies to work with those different types of data that you are getting. So again, I mean, even to get to that data, you should know the bare minimum, which is the operating systems, and something we'll talk about, you know, something we'll see that as well. So once you have the data center, and once you you know, you'll need a server, and on this there are, you know, different types of servers from the hardware perspective, and there are servers from the software perspective. So like you have mail server, you have database servers, you have DNS server, proxy server, whatever application. Again, I mean, it's same as, there is a placeholder. Whatever the name of your application, you can simply call that as a server. And within the servers, there are different types of servers that, you know, you'll see. I have another, you know, 3 common types of servers. You can have a blade servers, which is like a blades, you know, flat. And then you have rack servers, you know, you can have it in the form of racks. And then the tower server, which is like your home computers, you know, PC that you have at your home, you know, those cabinets, you know, like that. So these are the types of the servers. And this is just a good to know information, information which you want to have, which will give you a great foundation to your understanding. And then you can take this, you know, this understanding to the next level by having a good understanding of the operating system, which we will, you know, will do a deep dive to that particular topic. So these are the things, the surrounding things, which will make up for our learnings, and that's why it's good to have information. And if you have seen this for the first time, I would recommend you go through the recordings and understand things that we have discussed, because these are the things, you know, there are things which you wanna like if you are a very technical person, like you wanna enjoy the labs probably. And then there are things which are not very technical or theoretical, which is very important for you, because when you grow in your career, you need these verbiage, you need this terminology of the ITs to communicate or to showcase your knowledge to your subordinate or your colleagues. Okay, so these are the hardware, within the server hardware types, and then there are server software types, which we talked about. The based on what type of application you are running, you can simply call that as a server. And on on the servers, when you have the servers, the next thing that you need is the operating system. You simply call them OS. And within operating systems, what we have is we have couple of types. We have desktop operating system, and then we have server operating system. Again, I mean, the word server is coming quite often, right? You have server hardware, you have server type, you have server OS. So everything that is there on the server, you're gonna have, generally they are called servers as well. So right now we are looking servers in the operating system, right? Here the server in the type, and there was another thing which I did not write, the server software type, which could be your mail server, TP server, DNS server, Exchange server, whatever application you are running, right? Let me just say X server. Whatever application you are running, that is a server. So you have server everywhere. You have the server. Now server in the operating system. Now desktop is something everybody knows. We have Windows, Android, iOS, Mac, Linux. These are the desktop versions. Linux is the new addition to the desktop world, or even the Android and the iOS as well. If I say Linux is the newest addition, which was actually came first in early 2000, then Android and all of iOS, they came in 2007. So they are even the Linux is older than the Android and the iOS. So if I'm gonna list down Windows and Mac as the operating system, and then we have Linux, and we have the mobile ones, Android and iOS. So these are the desktop where you have the graphical stuff, because on the desktop you're going to have the graphical, and this is created for the end users, right? The users who may have the understanding of the IT or may not have the understanding of the IT or the application of the software. It can be, again, the two worlds that we have in the IT, the sysadmin and the developer world. Developer and sysadmin can also use these desktop as well for their usage, and generally everybody is given the desktop to do their day-to-day activities. And then we have servers. In the servers, there are different types of operating systems we have, and the most dominant operating system in the server is Linux. And Linux has probably around 80 to 85% of the market share, I would say, or the usage that everybody uses, because they are robust, they are secure. Unlike other operating systems, they are fast. And the other competitor that we have is the Windows servers. And wherever you have Windows-based application like Active Directory, you have Power BI, any other Windows service, right? Microsoft is the IT company that has a lot of product. They're not just providing service. I mean, they don't provide service like the other companies does, right? The IT tech services who actually will provide the service for someone who's not very good in the IT, like some pharmaceutical companies. They're like, okay, I don't want to do all of these things. Let me just outsource it to some IT company, and they'll outsource that whatever going on with the business, right? They'll outsource it to some IT company. So Microsoft is not that type of a tech service company. They are more into the product company who has the product in every segment of the IT. Like you name it, they have the server, they have their programming language, they have their we'll talk about they have the desktop, which is the dominant. I mean, so on the server side you have Linux, which is the dominating, and on the desktop side you have Windows that dominates. And other than that, there are a few more operating systems, like you have AIX and Solaris, and I think there is a new one from the Mac as well within the server. But again, right now the dominant is Linux, and everywhere the BSD is also there, one of the servers. But Linux is the one which is a very dominant operating system, and is Linux is the thing server which we should also we should know. And that's the class is about, where we will explore the Linux, and we'll understand everything that we need to know in order to get started our career, whether we are working in a DevOps, whether we are working in the networking, whether you are working in security, whether you are in a development, you do any kind of thing in the IT stream, you'll have to deal with this operating system, because everybody is using Linux everywhere, pretty much everywhere. Windows and others, they are just a need, because you can do, there are certain Microsoft based applications that only works on the that works very well on the Windows operating system, and that's why we want to go for that, because they keep easy integration, they keep it easy. Now Microsoft need to sell their product, and people are not buying their product, they're not buying their operating system, so they make certain things a lot easier to work with. The licensing requirement, the integration requirement is a lot easier on their operating system. So they do have a lot of services which is very much used. I mean, one of the services, like pretty much everybody uses, is Active Directory for their directory services. Active Directory or AD is one of the Microsoft service which almost 95% of the companies, they use Active Directory for their directory services. When we talk directory services, is basically the resource management, the users and other resources like printers. Main is the users, like you can keep the user password, username into Active Directory, and then from there you can pretty much integrate it to any other systems. So when you work for an organization, you use a username and password to log into your laptop, right? To get into the session, and then same username and password you'll use to AWS console or Azure console, or if you have some other application, you'll use that. So same username and password is working everywhere. Even to log into the Windows servers that you have created there, you're going to use the same server. So Active Directory is dominant directory services. It's one of the directory services which is very dominant, and it's used very commonly. So Microsoft has that, and if anybody is using Active Directory, they have to use Windows, because it only works on the Windows operating system. I've not seen any implementation where Active Directory is used on the Linux. Now there are different, they have the .NET application, they have the C# applications, which you can go ahead and run on the Linux servers as well. But there are certain applications, and they also have their own web servers as well, IIS. They have their, everything. They have a lot of things, and for that product, people use, or companies use, Windows as an operating system. Otherwise, the majority of them on the Linux, right? So let's take a look into the little bit history of these hardwares, and also we'll come to know about the history of the operating system, which we'll keep it for the tomorrow, because the introductory session was only to get to know about the IT data center and the virtualization. Tomorrow we'll look more into the open source movement, which we'll just touch base upon today, but we'll take a good look at the open source movement, and because the open source movement have gave a birth, or at least pave the way for the Linux operating system, which we'll see tomorrow in the tomorrow's lectures. So now computers or hardwares, humans had the need, human had the data, the data that they have passed from generation to generation by verbal communications, right? But verbal communication, you cannot trust the authenticity, right? You want to need some kind of a medium where you can store the data, and people used to store that in books, in papers, and that's how they have actually passed from generation to generations, right? And verbal communication is the the verbal means is the hardest one, because you cannot preserve each and every word. Like if I get a message, I'm gonna actually change the message the way I have understood, right? You hear those Chinese whisper game, right? A person says something, and there are like 14, 15 or 20% in between, and whatever the first person has said, and it's transmitted all to all of them, and when you reach to the last person, the message is completely different, because whatever he heard, whatever he thought, he just put it in his own in his own idea or in his own language. So the verbal transmission exchanging, passing the data from generation to generation is the hardest of them all. It's not very easy. So that's what people used to do, and then they came up with a lot of different tools or mechanisms. So you can always go on the internet and read the blogs, see the videos, the history of the computers, and they'll probably talk about from the Roman era, from 2000 BC and all those sort of things. There are different tools that we had, but we'll fast forward to maybe 100 years later, and what we had. So one of the company that is considered to be the pioneer or leader in the hardware manufacturing right now is IBM. So IBM is been around. IBM is the only IT company, I would say, which was doing the hardware manufacturing, and now they do service and have a lot of products as well. IBM have their own cloud, and just like Windows, IBM has a lot of products as well. I mean, to build a lot of products, you just need money. Like everybody is doing in the market. Okay, let's just let us we do as well these things, right? That's what they do because they have money. They can invest that. Okay, everybody is doing the cloud. Let's I can also do that. I'm also a leader. Like Oracle is also a leader, so they have their own cloud. VMware is also a leader, so they also have their own cloud. So they have money and they're just pretty much getting their hands on everywhere. That's what all the companies they do. Whatever is there in the market, they need a competitor. That particular product needs a competitor, and let's create a competition for them. That's so that's how they're doing it. But my IBM have been around for a very long time, and they had they had manufactured a lot of devices, a lot of hardwares, the typewriters, printers, calculators, because these were the things in the early 19 era. The corporate businesses, right now, the corporate businesses have data centers. They have a lot of data centers. They store all the information on the servers. But 100 years back, they didn't have data centers. They didn't have servers. They didn't have actually computer or any operating systems. Everything was there, just a calculator, typewriter, and the printer was also invented, right, at that time. So in 1900, there was there was this machine called tabulating machine, and this was like all the big corporates or big businesses would have it. Their infrastructure, as a part of their infrastructure, they would have a lot of these, and they'll also have the calculator and printers and typewriter. But this tabulating machine was it had calci plus printer and typewriter. And this was like a huge invention, combining all three of them together. Like all of the companies, they want to have it, right? And all of the big corporate businesses, whatever was there at the time, they were their infrastructure was made up of this. So you have a lot of tabulating machine that people were using, and it actually dominated for next 20-30 years. Now there are different versions are coming up, just like the servers, right? There are different Intel processor, the AMD processor are coming up, the different hardwares are coming up, the manufacture, the build, the different types of the RAM series are also there, the memory storage is there. We had magnetic disk, now we have SSDs, and then we now also, the new means of the storage are also coming up. So the new inventions was keep on coming onto this, but the core functionality was that it combined all of these and dominated for next 20-30 years. And fast forward to again, if you fast forward to the 50-60 years, IBM created the first server of its kind, and it was IBM 360, which was from part of the mainframe series. And you'll hear this name if you work for organizations which has been around for probably 50-60 years. They would have some mainframe servers, and in the 70s, 80s, the mainframe was at its peak. Like everybody was using mainframe. All the big organizations were using, the big corporate, the government, and the industry, the universities and the colleges, who could afford it. And this mainframe was not like the servers that we have. The mainframe was IBM mainframe 360 or IBM 360, what they used to call it. It will occupy the whole house. Let me show you, one of the images from the online. So this is the mainframe, and you can see the image. Right. So you had these big servers that would require the size of the house, and that was there. Now today we have the storage was also quite huge, and all you could store in the kilobytes. You could not. Right now we are storing terabytes and petabytes. That kind of storage we have. Back in the day, we have this huge, that will fill up your whole house, and all you could store is kilobytes. The KB, which doesn't even matter nowadays. Nobody talks about MBs and KBs. People talks about gigabytes and petabytes and terabytes, those sort of storage that we have today. So that's what IBM came up with. And at the same time, there was another thing was going on with the operating system, which we'll touch base upon tomorrow. So IBM actually got the servers. Now, in order to work on the servers, you didn't have the operating system back then. The operating system invention was also done by two of the genius, the Vichy and one of his colleagues. So we'll see that tomorrow. When we talk about the history of the operating system, which is our Linux. Right now, we are just looking into the different types of the hardwares or the infrastructure in terms of the server hardwares have been invented, which has actually given inspiration, or which have actually paved the way for what we have right now. Whatever we have would not have been possible without of these groundbreaking invention that these companies or these people were doing, right? So they deserve credit. I mean, people were able to reach the moon not because somebody out of the blue thought, okay, let's just build this and let's go to the moon. I mean, all the research that was done by the previous scientists for the thousands and thousands of years, the data was collected, and based on their invention and their groundbreaking inventions, it was possible for people to move to the moons, right? And similarly, whatever we have is all because of the people that they have done in the past, and it was possible for us to have a computer which is as small as that fits in your hand right now. And the the first lander that went to the moon, this guy Armstrong, he went. That has about like in some KB, the RAM was some KB, which is less than what we have in our in our mobile. I mean, it was in that RAM that the lander used. It was in some megabytes, which is which fits right now in our hands, right? So that we have gone that far right now in 50-40 years of time. That have the progress have been quite significant and quite impressive as well. So 1959, the mainframe from servers came, and the era of the servers, the IT infrastructure, and the data centers started from here. So people would have servers, different mainframes, and anybody who knew mainframes even till 80s and 90s. I mean, that guy was just the way today the DevOps and the DevSecOps and other like data engineers. They are like they are like a hot property. Anybody knows this skill set, they are in a big demand. Similarly, that was the case 80s and 90s. Virtualization was the case in 2000s, and cloud was the case in 2010s. And now we are talking about different types of data techniques and data transmission, data working with the various data. Because we have now the power data. I mean, people had a lot of data, but they didn't have the power to process the data or to store the data or get meaningful stuff out of their data. But now they do have the power, right? The power system is there, the application is there, and those are all possible. So these are the hot skill set of the market right now, and this will become legacy tomorrow, right? The cutting edge of today is the legacy of tomorrow. It's a thing in the IT, and IT is a very volatile nature. It will keep on changing. 5-6 years later, something else will come up, and then everybody will have to learn that. I mean, and you'll have to keep their mindset as well. If you want to work, if you want to be there or survive in the IT, you'll have to keep on upgrading yourself. Okay. Coming back to our journey to the different hardwares. Then within the hardware, the personal computers were personal computers were invented by none other than Steve Jobs and Steve Wozniak. I think they were the two people who came up with this idea, because at the time, all these IBM dominated. Now IBM tried to make it as small, very small. It was not IBM 360 all the way to 1980s. Like 20 years later, they were not using the same thing. It was grown. It was shrunk to very quite significantly, and something that you could fit like a table size of the servers that you had. But these people, they came up with even better. They came up with the personal computers, which would now these were the servers like small household or a common people cannot afford. It was so expensive. Only the big businesses, corporations, universities, and government agencies, only they can afford it. A common person cannot afford these kind of servers if they want to learn. People used to learn in the university and they also wanted to do something, but the sad reality, they could not afford because it was so expensive and not portable as well, right? And this is where Steve Jobs and Steve Wozniak, I mean, they came up with this idea of personal computers. And another thing was, I mean, if you are a technical person, it's fine. You could work with the server, all those black and white screen that you have. But if you are not an IT person and you still want to have this for your household, I mean, you don't know because Steve Jobs knew that we want to keep things user friendly and that will sell. And that actually he was right about that, because he was not a very technical person. He was more onto the strategic person who would do the marketing and sales and bring the new ideas that that can help the business grow. And one of his idea was to keep it user friendly, because he felt or he knew that if I could make it user friendly, I can add some graphics and make it easy for the users to use, then I would be able to make a lot of sales. And that's what he did. So they came up with these personal computers, and that actually allowed everybody, even small companies or small houses, to own a computer, and they started buying the computer. Still, it was very expensive, but affordable, right? And people who wanted to have the computers for their kids for their learning purposes, they could now buy it. So PCs or personal computers came into existence. Steve Jobs started it, and Bill Gates took it to the different level, and that's a complete different story, altogether, which you can always go and explore. At the same time, the internet was also starting. People's, the the other companies, the ARPA was formed, and all of these, the mainframe servers and everything that is happening is all because of the war. Because there was a World War II, that so many different types of machines was invented. One of them was Enigma. There was a movie was also made on that, right? To decipher the code that was sent by the German military. So one of the British person who created a machine called Enigma, and that was able to decipher, and they were able to prevent a lot of they were able to prevent the war damages which would have been caused by the German military. So the war have actually made given a rise, or actually brought a very good competition, and the government started investing in all those because they wanted to survive. You had these different nations fighting each other, and even in the 60s era, right, the Cold War was going on, and again so many inventions was going on. So all of these inventions and all of these fast the invention of these technologies and the tools was possible because there was a war going on the other side, right? So war actually have given birth to a lot of these things. And at the same time, internet was also going on, and internet was also going on because of the war that was there, right? So ARPANET was formed as well at the same time, but we'll see that later for the internet. Here, after getting a personal computers, the client server architecture, right? The client server, was also computing started. The client server computing started, where you have client and then you had servers, and this is where those corporate offices were opened up, where people would go and work from one location, and servers were stored on the another location. Otherwise, you'd have to literally sit wherever your server was. A personal computer was invented, and that personal computer actually acted as a client. And the servers which was there by these big companies like IBM and others, they were kept in one location where you know humans were, a frequency of the humans were reduced. You don't need to be present all the time in order to work with that. You can work it from the remote location. And the client server, the birth to the client server computing was also in 1983 was given. During the same time, in the same, I would say in the 80s, around the same time, 1987, a very good, in 1983 itself, actually, a movement is started, and that movement was for the free software movement, something which we will see tomorrow in a good detail, because that's related to our operating system topic. So a GNU movement was formed, and GNU is a recursive definition, which means GNU is not Unix. GNU not Unix, actually, there's no not. So every time G stands for GNU, and then if you want to know what the GNU is, then again, it's a recursive definition. It's a recursive way to do that. I mean, that's what the IT people would do, right? There are a lot of recursive ways they'll put, stuff. So GNU is one of the kind. I mean, a clever way to put it around. And Bison is the flag, or is how it's represented. So GNU was formed. There was this guy called Richard Stallman, and the name that you want to remember, because he's the guy actually given a birth to the open source movement. He led the people to protest, and they were able to actually come up with this. So GNU actually they protested for 3 years. They started their protest 1981, 83. He formed a lot of university graduates and the university students, and they protested. And the free software movements, he started with the free. So GNU started, and it was formed, and free software, the Apache Foundation, the other foundations that we have from where we actually get this open source software was also came into existence around 1987. And then there are different foundations came in about where we could get where you could get softwares which was free, and again free as a freedom. That's what they say in the open source. So we'll see more to that tomorrow. And there was in the same time, 1987, another operating system was created by one of the college professor, and that was from that operating system was Minix. And here in the 1960, right, the Unix operating system was also created by the person, the Richie, who's also invented this the language, the C and C++. So they also had come up with the operating system called Unix, and we'll see that more into about the Unix operating system tomorrow. But in 1987, there was one more operating system which was created by a professor, and that actually was based on the GNU software and the Unix operating system. It was inspired by Unix, and it uses a lot of GNU software which was available as a part of free software movement. And from the Minix, because it was just for it was created for the college people, for the students, for the learning purposes. So it was not business ready. It was not that mature that every business can use it, and it has few loopholes. But actually, that was the operating system which paved the way, and what we have right now is Linux. So Linux was heavily inspired from Minix, GNU, and the Unix, which is the mother of all operating systems. We'll look into that tomorrow. And that's how the Linux came into existence. We'll see that as well. And the name the Linux also have a very good history. Few of you might be knowing. If you're not, then wait until tomorrow to find out. Otherwise, you can always Google and find it for yourself. Here, this is called Linux. This is called Linux. This is called Linux. Based on like which type of person you are talking to. US people, they have a tend to pronounce I as a I, right? If normally we say multi, but US people call multi. right? For whatever reason. So they have a habit of saying I as a literal I. They don't say I as a E. So they lot of you see a lot of people in the US, they'll call it Linux, or some people will call it Linux, and some people also call it Linux, right? And European people call it Linux, but the actual pronunciation is the Linux. The inventor himself said you should call it Linux, not any other pronunciation that you have. So anyway, that's about how you want to pronounce, and you might hear a different pronunciation based on where you are. And fast forward to a few years, the different programming. Now this was the time where a lot of programming languages actually came into existence: the Java, Python, Ruby, and the others as well. And around this same time, SAS was also one of the offering. Salesforce is the company who came up with this first SaaS product, and actually that actually again created a road for the cloud computing. So SaaS based software was created by Salesforce, where you can just use internet. So internet was already there at the time. The 90s was also the era of the www, where people were using everywhere, right? Everyone used www websites, and so internet has become common, and Salesforce was the first company who came up with the SaaS based software, which actually given a birth to the cloud. And this was one of their cloud offering, and they are considered to be the pioneer, but they're not at this time. It doesn't qualify as a cloud computing what we have, because cloud computing is cloud computing because of the IaaS. This has actually brought a lot of flexibility, and a lot of companies have felt confident about moving to the cloud because we have infrastructure as a service. And thinking infrastructure as a service on the cloud was something unimaginable, like something you cannot think, because that's impossible for the people at the time. Same thing, another thing happened around the same time, around the 2000. That was virtualization technique came into existence. Now, this is where we'll spend some more time today before we wrap up for the day, talking about the virtualization, because for these two inventions are very important, and because of these two, what we have today is the cloud computing. If there was no virtualization and Salesforce hadn't come up with the idea of the software as a service based offering, probably this idea would not have been AWS would Amazon would not have came up with would not have had this idea to go about implementing something like that. So virtualization and this plays a very vital role into the cloud computing. And we'll see a little bit about virtualization. I mean, what is the virtualization, and what are the different types, and what it is. I mean, why there was a need to have this virtualization. So servers, again, now there are hosting services. Within the server, we have the hosting types. And one of the hosting type is of virtualization. One of the hosting is you want to have is bare metal or bare iron. Bare metal or bare irons is just the server, which a server like this. You have a server, right? I mean, you have the physical server. So basically, you have a hardware, and on top of hardware, what we have the operating systems. So we're gonna have operating system here. And again, we know the different types of the server operating system, right? We've already seen those. We're gonna have OS. I mean, you have kernel in between, but let's just keep it. So let's just make it OS only. So there is a kernel, and we'll look into kernel. We'll talk about kernels. What is the kernel, and what kernel does, and the functionality of it as well in the detail. And then we run our application here, right? Whatever our application. If I'm running web application, then this becomes my web server. If I'm running a DNS application, then this becomes my DNS server. So that's how the servers were before 2000 or before virtualization, and these were called bare metals. Even to this date, these are called bare metals. And what bare metals have actually become is we call it a dedicated tenant. And you'll get an idea about this, right, just in a moment. So hold your thoughts if you have any questions, because that will be answered, like what are these. So bare metal or dedicated tenants is where you just have your application. There is no neighbors. So we have a problem of noisy neighbors in the virtual. When the virtualization came, the another problem also came along with that is of noisy neighbors. So first we'll try to understand the problem statement of virtualization. Why do we need virtualization? So this was your setup before the virtualization came into existence. You have hardware, you had hardware, operating system on top of that, and the application running on top of that. Actually, that's the same setup you have on your laptop as well. You have your laptop, which is your hardware, and on top of hardware, you're running your operating system. And on top of operating system, you have all your different applications that you're running as well, right? So you run various applications because it is not intended to work as a server, because it's more like a home computers that we are running. So we'll only run few small applications, and then we'll shut them down as well. But on servers, you want to run some dedicated applications like a web server or database server or DNS server, proxy server, mail server, and the directory services, right? The ED server as well. So different services, and that actually makes up for your server. And so the problem was, now these servers are always, the configuration for the servers are they're like this. So you can have a one server, and that's the type of the server. Let's say this is my web server, and this is of, I'll keep it for 64 GB and 16 core. So this is my one server, a web server. I can also have another server, because I'm a company, just giving you an example. Let me just put the few servers. So I have a AD server here. I have a DNS server, and I have the mail server. And all of these servers are of the same configurations. Okay, so, and then I have a lot of application servers, right? Let's assume that I have around 20-50 total servers. Now, in order to store these 20-50 servers, first thing I would need is the space, right? Because I would need a lot of space. So first thing is the space, because there are like 50 servers that I have, and it would occupy, space, no matter how efficiently I put them together, but I would still require some space to have these 50 servers. And then the power will also be there. The cooling will also, because these 50 servers, they'll generate heat as well, because they're running all the time, right? I'll have to keep them running, all the time. And then the resources as well. So you have all of these you have all of these issues because you have just one server, and they are occupying a lot of spaces as well. They require a lot of power as well, and then in order to cool them down or calm them down, you're going to need a lot of cooling as well to cool the systems. These are the problems, which is fine, right? The other problem that we have, that my web server is not fully utilized. I have 64 GB RAM and I have 16 core, but I'm not using 64 GB RAM or 16 core 24/7. Right? So that's the same case with this. So I have a workload on the web server around 12 to 4 p.m. This is the only time when I'm using around 60 GB of RAM and around 12 core. The rest of the time, so between 12 to 4 p.m. I use that, and between 5 p.m. to 11 a.m., all the way, that's about like 20 hours. My usage is hardly 4 GB RAM and 1 or 2 core. That's enough for me to, because no traffic during after. This is the peak time. This is the only time I'm having a traffic. So what's happening here? Like 20 hours, rest of the 20 hours, I'm wasting the 60 core that the way, because I'm only using the 4 GB of RAM. So the rest of the resource is being wasted. And I cannot run this server like 4 GB for the 20 hours and suddenly bump it up for the 64 hour, because that's not possible. I mean, in the cloud, you can do that, but still that's, there is a way to auto scale and auto scale. But, you on cloud, it's at least a possibility, right? Now, how do you achieve that? That's a different story, because it's not that easy as well to achieve that in the cloud, but you have the possibility. But on the on-prem, you didn't have that, right? These are the on-prem solutions we are talking about. We are talking about back in the 90s, before 2000, right? When you had this server and the traffic was only there, the peak time was only there where you were using 60 and 12 core. The rest of the time, the 20 hours, you're not using, you are hardly using resources, right? So a lot of resources are wasted. And that was the grave concern for everyone. And that's the same scenario you have. Now you can imagine that this server probably have the traffic early in the morning or late in the evening, and same case with that as well. So we needed some way to save the resources, the spill or the usage that is causing to the business unnecessary wastage of the money, the space, the power, the cooling. And this is the very important thing. Before 2000, there was no technique which would allow you to run two application or two operating system on a one server. There was no isolation. And running web server and AD server on this, again, you had compliances. You cannot run that as well, because if you're running this as a web server, probably you're running this on the Linux, this web server, right? So you have the technical limitation as well, and you're running this on a Windows server. So you can't combine these two. And the mail server and others also have a different requirement and different set of technical difficulties plus compliances difficulties. So you cannot put them together, because you need a different operating system with different layer of isolation, and that isolation was not possible at the time. So these are the issues were happening, and this was a challenge, right? And this challenge was solved by three genius, again, college fresh outs, and two of them have gone, they've married each other, and I forgot their name, but they actually came up with a technique called VMware. So just the way you had hardware, software, they came up with something called virtual machineWare, VMware, which is not used nowadays. And that's the reason why I'm not writing VMware here. I have written virtualization, because VMware have gone on to become a company, and they have patronized the word as well. So you cannot use in your official documentation. For conceptual understanding, you can use the word VMware, but since you cannot use the VMware word because it has become a company, and the word is patronized by the company. So they came up with that technique of the virtualization, where they came up with us, a concept of hypervisor, where you can actually split the cores, split the resources, and split the kernels as well. And on one physical machine, you can run more than one operating system. So previously a bare metal, which means you can only run one server, and what we have now is the virtualization, where you can actually run more than one operating system. So you had the same scenario of a hardware, and then we have operating system. Then we don't have operating system on the hardware directly. What we have here is called hypervisor. So we're going to have a hypervisor. On top of hypervisor, I can have now operating systems. I can have multiple of operating system, and on top of that, I can have my application. So we have called hypervisor, and this is our OS. I can have a Linux OS now, I can have the Windows OS, and I can run my applications here. So this was made possible by a technique called VMware, or virtualization technique. And within that, what we install is the hypervisor. It's just a piece of software which will allow you to run multiple software. So hypervisor is just a software And again, there are different types of hypervisor that are used, and let me put few common names here that are very used. So ESXi, you'll hear a lot about it because this is the hypervisor by the VMware. Right. And then we have, like I said, Microsoft have their presence everywhere, and I'm only writing the ones that are popular. And Hyper-V is something, if you were to use Azure Cloud, because this is from Microsoft, and of course, Microsoft's going to use their virtualization on their cloud, right? So Hyper-V is used on the, on the Microsoft cloud, on the Azure cloud as well. If you are using Azure as a cloud, so that's a technique that that's what they're using. And then there was this couple of open source, and it all started with the Zen server. Actually, Zen should have been the first one. So we have Zen server, and right now Zen server is used by Amazon as well. So on the AWS, I'll show you this as well, right? How to check the what hypervisor technique that we are using. So Amazon uses Zen server for all their virtualization technique, and another one that Google uses, and which is also quite common, is KVM, which is by TCP. Right? So these are the few hypervisor techniques, and these are actually the type 1 of the hypervisor. So these are the type 1, and type 1 is generally used in your data centers, in the, and then you have type 2, which is for your home usage. What happens in the type 2? You have operating system, so you have the hardware. On hardware, you actually put the operating system, just the way old time, right? You have the laptop. On the laptop, you actually have the operating system, because we are talking about type 2, which is created for the home usage, for the education and learning purposes. And on top of your operating system, we put hypervisor, which is of type 2, and then we can put operating system, multiple operating system if you want. But again, you're going to need that much resources, and then you can put applications here like this. Let me quickly put the name. So we have hardware, we have OS, then we have hypervisor, and then again we have OS. So this is the hypervisor type 2, and probably you may have worked with these types as well. We have VirtualBox by the Oracle, VMware Workstation by VMware, VMware Fusion, something we use on the Mac, and Parallels. And there will be few others as well, right? These are the common ones that I've listed down within the type 2. And these are the common ones, widely used in the industry of the type 1. So you have this technique of hypervisor, which makes everything possible what we have, which makes the cloud possible what we have today, right? And what we say, so what happens, right, in your cloud, you have a one hardware. When you create an instance, when you create a server, so one of the server is created for you. So you only get to choose till here. You don't get to choose what type of hypervisor you want to use, right? When we talk about IaaS, you can only choose till you can only choose till here. From here onwards, you can choose what type of operating system you want, and then you can install whatever application you want, right? That's your IaaS. But in the bare metal solution, you can also choose the hypervisor, and that's a new type actually companies are coming with. They're also providing a bare metal solution. So that is also one of the cloud type that should come here. So bare metal solution, basically you can choose the hypervisor that you want. And on top of that, you can then use the operating system of your choice and then application of your choice. And when we talk about bare metal right now, normally the bare metals are referred to the dedicated tenants. Dedicated tenants is you have a setup like this. You don't have any other person sharing the same hardware. Cloud companies, what they're gonna do, they're gonna have this hardware of a massive size, and on top of that, they will put few, they're gonna have a hypervisor, and they'll create a one instance it will be given to you. Another instance probably given to some other person, another or some other company, right? If they are using the same region, and that's how they will the different. So on the same hardware, you have different companies. Let's say this company was, let me put some name, just hypothesize Walmart. Right? So Walmart was using this EC2 instance, and then you had probably a bank, right? Let's pick a bank, a Charles Schwab, CS, right? Some financial institute, and then some pharmaceutical company. Let me put some name, Pfizer, and I mean that wouldn't be the case because these are like a big companies, and they would always go for a dedicated tenant like that for most of the workload. What the problem, you run into so many problems because the compliance, Walmart probably, or Charles Schwab is the financial institute. They're probably storing data of the financial, and they're actually storing on the hardware where the Walmart also have it, and probably some XYZ startup company here, let's say. So the Charles Schwab has a lot of financial data stored on this server because physically it is the same server, and this startup server is also there. If this guy somehow hacks into the system, if he can come to this hypervisor and then go back to this operating system, you have that, right? So if they have some malicious user, I mean, it could be from the Pfizer or Walmart as well. So they have the first problem from the compliance point of view, that you are sharing the hardware. So there are certain compliances and norms where you cannot even share the hardware between other tenant within your organization. Forget about the different organization. Right now you are sharing the hardware with the different organizations. So you run into those sort of compliance issues where you don't want to do that. Second, you can have a noisy neighbor. I mean, this guy is probably doing some kind of a machine learning or some maybe he's doing a Bitcoin mining or something like that. He's consuming a lot of resources. He's creating a lot of noises. So we have a problem of noisy neighbor as well. You have a problem of compliance. You have the security issue, compliance issue, the noisy neighbor issue as well. But because you get it at a very cheap rate, you'll have to live with that because there are different types of isolations are there, but still certain compliances doesn't allow you to share the hardware as well with the difference. And at that time, you go for a dedicated tenant, sole tenant, bare metal tenant, different names. But the idea here is the whole hardware will be dedicated to you. No other consumer or no other tenant will be allowed to use any resources or create the virtual machine from it. You can, so if Walmart is using the whole server will be dedicated to the Walmart. Again, now this will come very expensive, right? If this server is of 128 GB RAM, which is not the case actually. I mean, what I've seen, it will start like this. You're gonna have configurations like that. So even if you want to create an instance of 1 GB, 1 core on the dedicated instance, you're gonna have to pay for this much amount because you are actually, they're reserving the whole physical instance for you, right? Because of your business demand, because of the compliances issue that you have. So that's what we have in the cloud sense. When we talk about bare metal, bare iron, we're basically meaning dedicated tenant. But back in the day, bare metal is what you have, like it's just iron server that you have, and on top of the server you install all sort of applications, and you get the job done. In this case, you don't do that way. You have it's all dedicated to you, so only you are using it. No other tenant or no other customers is allowed to come onto that server or use anything. So that's the virtualization, the different techniques, the different types, and where it's used and why it's important for the cloud, because this is what made cloud possible, and at least the idea possible. Now cloud has grown up to be a completely different beast right now. So it's not what it was there back in 2006 when AWS came up with that idea. Actually, 2006 is where they implemented the idea. The idea they had before that, and they collaborated with few other company, and they were able to successfully pull this off. And once anything is successful, all other companies will start getting into it, and that's what happened. The Google and Amazon, the IBM, all these big giants, they started getting into that as well. But our focus is going to be on the operating system side. So tomorrow would be the time where we'll explore more into this, the history of the Linux and history of the different operating systems that are available there, and how the birth of Linux came. And again, in the Linux right now is completely different beast as well. There are I'll show you few things within this which that will actually your appreciation will rise for the Linux and the flexibility and the different choices that we have within this. So with that, let's wrap it up for the day. I'll open the floor for question answer. If anybody has any, you can raise your hand and ask the question. If you don't have anything right now, we can